Hi, I'm Rich with Inside HPC. We're here at SC16 in Salt Lake City, and this morning we're at the CoolIT Systems booth with the CEO of the company, Jeff Lyon. Jeff, welcome to Salt Lake City.
Thanks a lot. We're happy to be here.
Well, thanks for having us. You know, I thought maybe we'd start at the beginning for folks that might not know. Who is CoolIT Systems and who do you help?
CoolIT Systems specializes in liquid cooling for IT, and now we're actually positioning our company as a solutions company so that we're taking the heating and cooling problem and delivering a solution that takes the heat right from the chip all the way out to the atmosphere.
Okay. Well, you see, we got a lot of components here. Can we kind of go on a tour? Can you show us what's going on?
Of course. So our company specializes in kind of a modular approach. So every time we come up with a new solution, it becomes one of our kind of Lego building blocks that can be then re-leveraged in new solutions and new configurations. So what we start with here is kind of what those modules look like. On this side, there are some important components that we do not make, but incorporate extensively in our products, which are the quick disconnect technologies. And this is a product that we've put together and sourced from STULZ Corporation, which we believe makes the best quick connects on the planet. And you can see the quick disconnect construction is all metal. Even the big ones and the smaller form factor ones have all metal construction so that they've got a strong, reliable wear life. We're going to have no issues. They are truly dry break because everybody's a little afraid of drips going down onto the IT system. So we decided that it was extremely important to not scrimp on that part of the technology. We also have some specialized products here which are for blind mate connections. And the blind mate is, if you can picture this being mounted at the back of a server, as it slides into to its mounting position, the blind connections that are taking place for network, for power, and now for cooling happen automatically. So that the mating side of this connection would be on a manifold, and that actually has some travel in it. So it can float and take up the mechanical tolerance that's necessary so that you don't have to have guide pins. It can be a very simple design, and then as it goes together, the connection is made. And it's actually a double seal as well still, so that when you disconnect it, you don't get any moisture drops, and effectively the use case of the server is exactly the same as it was when it was an air-cooled version. So we've got some small form factor radiators here as well. And what these are is kind of an offshoot from what we would do in the desktop space. So in some cases, a server design, they'd like to have a slightly higher powered CPU. Now what our closed loop solution is a slightly better heat sink. Right, so what it does is allows you to move a little more heat with a little less air, so that you can have that 250 watt overclocked or specialty SKU taken care of inside your compact box. So we make those as well. Down here, we've got a couple of solutions that are now deployed. This one is actually for the Fire Pro S9300 X2. We just actually deployed about 28 racks of these in a radio telescope. I'm not sure if anybody may have seen the release on that. So that was an exciting project for us. Likewise, we have the dual GPU solution for the K80 from NVIDIA. And so we've got solutions for each of these specialized cards. We also have the P100 from NVIDIA, and these are for RAM. So the idea being that as this gets slid down onto the RAM banks, we're actually using liquid flow to gather the heat from the RAM itself. Even though it's lower heat, so you're not going to get much more than, say, 10 or in some cases as much as 18 watts per DIMM. It's still difficult to grab all that heat if you have a lot of them inside a server.
Yeah, they pack them tightly together for those big memory systems.
Right.
Yeah. Okay.
So this is kind of an exciting part of the display for us as well. We've got new releases from Intel with K&L, which is this version right here, and its close cousin, Skylake version, which essentially looks exactly the same. You can't really tell the difference from the outside,
Yep.
but they leverage the same patented split flow technology that we developed for our traditional solutions and kind of the Broadwell and Haswell CPUs, but it's a much larger form factor. So we've got a very high density microchannel fin construction, and then that allows us to do a very efficient transfer of heat with very little flow. So we use good economy with respect to the amount of water we have to push through the rack.
So Jeff, looks like we've got some more Knights Landing hardware here.
We do. We've actually done a number of solutions. They're starting to roll out now, thankfully. And one of the things we're highlighting here on the booth are the number of OEM solutions that we've done. So this is an example here of a Knights Landing solution that we put together with NEC. They call it their Blue Marlin. We've done a great deal of configurations with a number of other OEMs that we've got displayed across the booth, and we can highlight each of them in a second.
So Jeff, what do we have here?
This is a Dell PowerEdge C6320, which is a very dense CPU configuration. It actually has 4 sleds that go into the back. These are actually slightly shortened tubes so that it doesn't look messy on the display, but it's a solution we put together with Dell and is now being actively marketed as an opportunity for people to have a very high density liquid-cooled solution from Dell, and something that we're really happy about and proud about. If you remember at the last show, we were launching the Lenovo solution. So now we're highlighting all of our other OEM solutions as well. So as you mentioned, we got NEC, we got Dell, and we have HP here.
Oh, yeah.
So this is pretty cool. It's a HPE trade and match server solution. So what's being done, as we talked about over there, we're using a small form factor radiator to be a little better heat sink. So the ability for this solution to dissipate essentially what amounts to an overclock processor. So this gives the added power envelope so that the power can be put up, the frequency clock can increase, and then the performance for that market specifically can be satisfied. So that's an exciting development for us, and we're encouraging folks to contact their HPE representative to have a look at these. Also with HPE, it's actually on the same HPE Apollo 2000 platform. We have a manifolded solution. So whereas this one over here was kind of putting all the cooling into one CPU, all internal to the blade, this one is actually a manifolded solution, so it would hook up to the manifold on the outside of the system so that we can enable that chip to atmosphere path. So the heat always starts in the CPU, and then we take it out from the CPU to the manifold, then to our heat dissipation solutions, which is what we're going to have a look at next.
Okay, Jeff, here we're talking about heat removal. What do we have?
Well, this is an extension of our AHX product concept, and it doesn't have an actual name yet. We're calling it Project Panorama, named after the ski hill. If you recall, we had Revelstoke was our big CDU that we did a couple of shows ago. So this is Panorama, and what we've done is actually made a relatively small load capable heat exchanger. So what this does is it hooks up to the manifold in the back of the rack, and this would actually slide into the rack. So it has a front to back airflow. So this is the intake here. So the intake comes in across the bottom. There's a large heat exchanger here, and then the air comes up, across, and then out the back. So this is our exhaust here. And you can see on the back here where we've got our supply and return mounts. We've got network status, facility zone sensor, So you can actually do external leak sensing as well if you wanted to wrap leak sense cable around the manifolds if that was an issue.
Yeah.
We've actually got dual redundant power supplies
Okay.
as well. Full reporting capabilities so that you can tell if a fan were to fail or if you had any other issues like flow or pressure.
Okay. So what kind of delta on temperature are we talking from input to output on something like this?
Depends on how you set the fan. Slower
Yeah.
the air, the
Yeah.
higher the delta.
Yeah.
But the capacity for this unit is expected to range between 6 to 8 kilowatts. So this is a pretty small, lightweight unit. Now, we do have a lot of people that have lower heat loads or sometimes half racks, and they would like to have this be a tool to allow them to use liquid cooling, but they don't necessarily have all the infrastructure, right? So the liquid-to-liquid heat exchanger, which is much, much better with respect to efficiency, this puts more load on your air conditioner. But it does allow you to get that high performance out of the chips themselves. Going next step up to the liquid-to-liquid.
Okay.
This is our CHX40. It's one of our best sellers. We have a lot of these being deployed every day. The nice thing about this is that it's got a very high capacity brazed plate heat exchanger. The ability for this to dissipate the heat really comes from being water to water, right? So we've got, even though it's a very small form factor, it's only 2U, you can do up to 40 kilowatts of heat. Now, we did find that the limitation for this product when you get to higher density racks was flow. We could do about 40 nodes with this, right? So we had about 20 liters a minute, and we try to gauge everything by about half a liter a minute per node. So the quick math suggests we can do about 40 or 42, but now we have racks that are having 100, 120 of those nodes, and even higher heat, like 60, 70, 80 kilowatts. So we decided to move from our standard here, and we're now in production with this.
Okay.
This is the CHX80. Now, this is a featured up version as well. So on the CHX40, we had redundant pumping, but they were in series, right? So it did have a backup pump, but you would have slightly degraded flow if you were to have one fail. What we've done instead with this model is we actually have 3 pumps that are configured all in parallel, which gives us N+1. So only 2 of them will be running at any given time. But what we do, in fact, actually once a day, is we switch we give each one a day off in succession. So it has an even wear life. And also, too, if you have your backup pump and you have one fail, you don't want to find out then that your backup pump doesn't work. So it goes through that rotation. It is customizable if you wanted to have it at a different cadence. And we also have a much increased brazed plate heat exchanger, so it has a much higher capacity, higher flow capability. We're looking, instead of 20 liters a minute, we're upwards of 60 liters a minute, so that we're able to push over 120, 130, 140 nodes with one CHX module. It also has flow measurements on the primary, flow on the secondary, pressure and temperature on in and out on primary and secondary. It has a diverting valve instead of a proportionate valve. So on the CHX40, we would actually just pinch off the flow if the water was too cold, right? So we protect against condensation. But with this, when we're dealing with much larger flow volumes, the facility guys prefer if they can have one constant flow going in and out. So we accept the same amount of water in and out, but if it's too cold, we just divert the water that we don't need so that we don't overcool the secondary coolant, so that we don't have condensation and rain starting to happen inside the rack. The control system, obviously it's still reporting in all of the various different formats that everybody wants. The other additional handy feature for actually commissioning is that it has an automated fill routine put into it. So you actually connect up the fill pump and fill kit So if it's, we prefer to actually ship it full, but in some cases we go into an environment where they would prefer to fill it on site, which is okay. We now have an automated fill routine so that you hook up the fill and the bleed valve and the power switch right on here, and the control system actually controls that fill process so that we guarantee that we end up with a nice fill, and we don't have to have any special skills on site necessarily to service the unit. Dual redundant power supplies as well. It's a fantastic unit, and we're starting to ship these out to customers now, so we're excited about that.
So Jeff, we're moving up the scale here now with some big capacity.
That's right. Everything that we've talked about so far is kind of scalable rack units. What we've got here is actually a row-based CDU. So instead of putting a CDU inside every rack, this much larger form factor CDU can supply all the secondary coolant flow to 12, 14, sometimes 18 racks at a time. So by scaling it up, we have an easier service point, but it depends on the customer what they prefer. This is a little more on-site installation burden. So we have plumbing of the secondary manifold that has to happen on site, and that's done on a custom basis based on the floor layout. But what we're most excited about today is, last time we were talking, we introduced the partnership that we developed with STULZ. And STULZ is our worldwide service partner. They're also a collaborating sales partner. And today we're showcasing the unveiling of a new product that we've developed and combined together. So I'll actually introduce the president of STULZ USA, and he'll take us through what that new product looks like.
All right, Jorg, thanks for coming on today from STULZ. I understand you developed the product with CoolIT Systems, and this is the debut world premiere right here today.
Kind of. Thank you very much for having us here. Yes, as Jeff already pointed out, this is the first joint project between CoolIT and STULZ. We actually wanted to talk about the story chip to atmosphere, meaning we want to bring together what CoolIT has to offer on the direct chip level cooling with liquid and the air-cooled section that STULZ can bring to the table and combine it in one element. What we see here is our first micro data center, and it combines the story of chip to atmosphere in one tiny box, meaning we have introduced here liquid cooled servers. We have introduced the elements from CoolIT here the manifold system. On the bottom we have the coolant distribution unit that Jeff explained earlier. And then here on the side we have actually a cooling unit fully integrated that will take care of the remaining air-cooled part of the overall system. Our chip to atmosphere is actually the story of fully integrating the liquid cooling into the overall data center cooling architecture. With liquid cooling, we still have a level of air-cooled requirements. In this box, we take care with this unit here. This unit provides a cooling capacity of roughly 25 to 30 kW. Meaning with the CoolIT technology on the bottom, we're capable to easily handle up to 60 kW of IT load in a single rack.
That's a lot, because from what I understand, you can't, like anything more than 40, you can't cool that with air. It just won't work, will it?
We have done this in the past, but it requires a lot of technical finesse and detail. Yep. By applying liquid cooling to it and taking just the remaining air-cooled section, we can do much more in much less space. Now, the key element here also, this is, as I said earlier, it's a fully integrated solution. All you need to bring to this rack would be some sort of a liquid chilled water loop or a dry cooler loop that you have on your building site, and power. That's it. It's a complete all-in-one solution, and it's also a building or a structure that can be located anywhere in a building. So you don't need to have any kind of conditioned room or any kind of conditioned space. It could be installed, for example, in an office space. It could be installed in a warehouse environment as well. So that serves multi-purposes. If we take a look at on the other side of this rack.
Okay. Well, here we are on the other side.
So this will be the front. This is actually the air distribution inside the rack. The servers would pull the air through. So whatever is not handled by the liquid approach, the air cooling would take care of it. Then on the bottom we have the CDU. The key element here also is each of these components have controls. So we wanted to make sure that we integrate also the controls to a level that a customer does not need to deal with controlling a liquid circuit coming from a company, CoolIT, and an air-cooled circuit coming from STULZ.
Yeah.
We wanted to make sure we combine everything up and have a single control element and an interface at the front of this rack to control both circuits.
So it really is a micro data center that you could just wheel up with a forklift, isn't it?
Yes, absolutely.
Yeah.
No. And again, it combines our, what I said, chip to atmosphere story, but you can think, if you look at this, it is a fully scalable solution. So this is a single rack application. You could picture it as a multiple rack application, or you could also go and apply this kind of idea of chip to atmosphere to an existing data center with a hot cold aisle, for example, installation.
Here we've seen the full range of solutions from CoolIT, and in addition with deployment from STULZ and a new micro data center. Any closing thoughts?
Well, I think it's just starting to get to that tipping point in the industry now where everybody's been talking about density for a long time. Now I believe between companies like STULZ and CoolIT Systems, we've developed solutions that really can support that high density rollout and make it a practical reality.
Yeah, I want to jump on it. The idea was from the beginning that we both have to bring elements to the industry that only in a combination really can provide a complete solution to our customers. So with what we have done so far, we have proven it, we have tested this technology, and we are now in the rollout, and we have seen already a lot of positive response. Because if you're looking even at CapEx for solutions like this, where people a lot of times saying, okay, it is an extra investment, it is a specifically designed solution, it is really not. If we do it right, it depends on the level, on how far we want to go with the liquid cooling. We can provide solutions that even from a CapEx point of view are already very attractive to customers. If you then take into consideration the optimization on the OpEx, it's a win-win situation.